Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and in this video we are going to solve another gate question. This question was asked in the year 2001 for 1 marks, and it is related to the topic of process management. So let's read this question. So the question goes like this: a processor needs software interrupt to, right? And the options are: option A is test the interrupt system of the processor. Option B is implement coroutines. Option C is obtain system services which need execution of privileged instructions. And option D is return from subroutine. So the first thing that we should do is that we should understand what is a software interrupt, right? So as I have already talked about software interrupts in great detail in one of the earlier videos. So the idea is that first of all, an interrupt is a signal, right? This signal is for the CPU. It is basically used to notify the CPU that there is an event that needs immediate attention from the operating system. And whenever there is an interrupt, once the CPU detects the interrupt, it suspends or halts the current program, the current process, and immediately transfers the control to the operating system. And then the operating system executes a special routine in order to deal with that, or you can say handle with that event. So this was about interrupt. And as you can see, there are two types of interrupts. One is the software interrupts and the other is hardware interrupts. So as we know, software interrupts are so basically the idea of dividing the interrupts is based on the source. If the source of the interrupt is from software, that is, let's say some user process, then it is a software interrupt. And the example of software interrupts are system calls and exceptions. Whereas hardware interrupts come from hardware devices like IO devices, right? So now that we have an understanding of the software interrupt, it is basically a interrupt from the software, and this interrupt will be used to notify the CPU that there is some event or situation that needs attention from the operating system. So as we can see, system calls are an example, or you can say system calls are a type of software interrupts, right? So if we see, this is the timeline of execution of system calls, right? We have seen this several times. So you can see there are two parts to this diagram. The blue region is where we are executing the user process, user instructions, and the red region is where we are executing the kernel code. And you can see in the lifetime of a process executes several system calls. You can see here I have taken two system calls, the read system call and the mmap system call. And the idea is that whenever the user process needs like a specific operation to be performed by the operating system on its behalf, then it makes a system call. These operations basically require the execution of privileged instruction or accessing privileged memory locations. That is why the user process cannot like do the task or do the operations that are done in system calls on its own. These operations have to be done by the operating system, because it's only the operating system, it's only the kernel which has the privilege to do those operations, right? In this case, you can see reading basically involves reading data from a file, and these files are present on the storage devices which are IO devices. Similarly, the mmap system call will be dealing with the memory allocation. Here we have hardware devices, and only the operating system is allowed to deal with the hardware devices. So it will require the execution of privileged instructions or accessing privileged memory locations. So that is why we need the user process invokes the system calls so that the operating system executes these operations on behalf of the user process. So as you can see, whenever a user process makes a system call, it is a software interrupt for the CPU. The CPU basically, when you make a system call, when the user process makes a system call, it executes the trap instruction. And when the trap instruction is executed, it is a software interrupt for the CPU. And whenever it detects it, it immediately transfers the control of execution to the operating system, and then the operating system executes the system call. So the system calls use this interrupt mechanism so that the execution can be transferred from the user process to the appropriate kernel routine. So now let's come back to the options that we have, and you can see here in option C it is written a processor needs software interrupt to, and option C is obtain system services which need execution of privileged instruction. So this is exactly the definition of a system call, right? When you invoke a system call, you are requesting system services from the kernel, right? These services are basically provided by the operating system. These are operations which the user process cannot execute or cannot perform on its own. It requires the kernel help. So that is why it makes a system call to obtain system services. And within the system call, you will be executing, basically the operating system will be executing the privileged instructions, right? So this is what happens in a system call. And in order to make a system call, you need a software interrupt, because whatever user process was being executed, when it invokes a system call, the control has to be immediately transferred to the operating system, and that transfer will be happening via the mechanism of the software interrupt. So option C is the correct answer. And you can see the other options are kind of not relevant to the question. Only option C is relevant in the context of a system call, right? We have a software interrupt, and the example of software interrupt is either system call or exceptions. And this system calls is required because your user process will request system services where the privileged instructions will be executed, right? So a processor needs the software interrupt mechanism to have a system call. So option C is the correct answer. So guys, this was it for this video. Thank you very much for watching, and I will see you in the next video. Thank you.